this getting recorded?
Yeah, recording he will provide to you. Okay.
Okay, fine. So you are doing the recording.
Yes.
You are doing from your side. Okay.
Okay. So WebSphere MQ nowadays again we are initially it is into the IBM MQ series. It is calling it as a IBM MQ series. Okay. After that again it is calling it as a WebSphere MQ. So now it is calling again it is calling it as a IBM MQ series. Okay. So here the first is the planning. First part is the planning and installation. Planning and installation. Okay. So once organization they were decided to use this WebSphere MQ as a middleware integration tool between the diversified application. They want to integrate diversified application. They were planning to use WebSphere MQ or IBM MQ series. First, as a middleware administrator, so we are involved in the planning and installation activity. Okay, so in the IBM MQ series, we have two components. One is MQ server, another one is the MQ client. We have two components, MQ server and the MQ server and the MQ client. Okay, so if we install the MQ server, okay, we can create the one object called it as a queue manager. Okay, so the queue manager responsibility is okay, providing messaging and queuing functionality. Okay. Providing messaging and queuing functionality. So queue manager also having objects. Okay. So those are we are calling it as a queues. Okay. Channels. Okay. Listeners. Okay. etc. Okay. Topic subscriptions. All these are the queue manager objects. Okay. So, for example, in the database, we have any kind of database, we have a table, right? Okay.
Yeah.
Okay. Okay. In the same way, in the WebSphere MQ, we have an object called it as a queue manager. So the queue manager responsibility is providing messaging and queuing functionality. Okay. So basically, MQ server is the licensed product. Okay. You have to pay the license. Okay. So when it comes into the MQ client, okay, it is into the free. Okay. It is into the free. When it is free, once we have a MQ server license, okay, okay, so okay, this MQ client is MQ, okay, once we have a MQ license, okay, then it is into the client is the free. Okay, so here there is no queue manager object. 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 Okay, there is no queue manager object. Okay, no queue manager object means MQ client won't provide any messaging and queuing functionality. Okay, so just it provide interface. Okay, so means a message queuing interface to connect the queue manager. Okay, using client. Okay, using client Okay, application can connect into multiple destinations. Application can connect into the multiple destinations. Application can connect into the multiple destinations. Okay,
Okay.
and also
Yeah.
you can
So
provide,
I have a question here. So can I ask it now?
yeah,
Yeah. So basically, yeah, if we need to integrate different applications, do we need to do it through MQ clients?
yeah. You can use MQ client also. Okay,
Okay.
so using MQ client, okay, MQ client, okay, so we can provide a failover functionality. You can provide failover functionality. You can provide the failover functionality. Okay, so this is very important for any organization. Failover is a very important. So using MQ client, okay, without any clustering of workload distribution environment, you can provide the failover functionality. Okay, so okay, so in planning, so where we have to install the MQ server, where we have to means we have a number of applications in our organization. So each application want to use MQ server. Each application is using MQ client. Okay, that one we have to decide, and we are performing the installation activity. Okay, so
Okay.
here we have a
So for
various
each of the application, do we need to install an MQ client?
now, yeah, you can use MQ client. Use MQ client. You can connect without MQ client also. You can connect. Okay, using
Okay.
CCBT table. Okay, without MQ client also you are able to connect. Okay, so MQ client is not a mandatory to install. Okay, so there are few
Okay.
jar files
And
are
one more
available.
question before we go into the next point.
Uh,
What do we mean by failover functionality?
for example, if my application is connecting, I have a two queue managers. Okay, my application is connecting one queue manager one. If that is not available, application automatically it will connect the queue manager to and will write messages. Okay, for
Oh,
example,
okay. So one
okay,
is not available and the other is
yeah,
available. You
one
go into this and
directly
okay,
it will write messages into the second queue manager. Okay, so
okay,
we done. Okay,
okay,
so so here one is a MQ client server architecture. Okay, MQ client MQ server. Okay, basically we are calling it as a client server architecture. Okay, MQ client. Okay, MQ client server architecture. Okay,
okay,
so here what happening is here. So basically in the WebSphere MQ, our main intention is, okay, so establishing a communication between the diversified apps, right? Okay, so I have a app one to, for example, I have a app, some 100 applications. Maybe in an organization, all these applications are interacting. For example, it is into the database. Okay, so my database is into the, for example, it is into the AS400 operating system. This is into the DB2. So here I am installing, means I am AS400 system. I am installing my MQ server. Okay. Once we install the MQ server, so here we are able to create a queue manager one. So here you have an option. So for all 100 applications, you can create a one queue manager. So otherwise, if you want segregate, okay. So I want each application one queue manager, but all applications doesn't require a one queue manager. see each queue manager, because few applications are generating thousands of messages. Few applications are generating hundreds of messages in a day. Okay, few applications are generating very less messages. For that application, we doesn't require one specific queue manager. Okay, in a queue manager, we can create a number of queues. So there, we can create a application specific queue. For each application, we doesn't require any for a specific queue manager. Okay, so here this application will use this queue manager using MQ client. Okay, so using MQ client, it will connect the queue manager. It will connect the queue manager. So for example, here my queue manager is a queue manager 1, and it will write messages on a queues. Okay, so basically queue is a safe place to store messages. So always application will establish a connectivity to the queue manager, then it will write messages in a queue, and in the same way application will establish a connectivity to the queue manager. It will read message from the queue. Okay, so in here in application 1 to 100, I don't have any MQ installation, server installation. So I have a MQ client installation. So we can install the MQ client, or we can use jar files we can connect into the queue manager. So for this is according to our scenario, we can create a queue specific application specific queue manager. So in the application and we don't have any MQ servers. Okay, so we don't have any queue manager. Application will use MQ client and it will connect the queue manager and it is writing messages. So then the target application DB has to respond, right? Means it has to read messages and again it want to respond back to the source application. That is what happening. Request and reply scenario is happening in the organization, right? So applications doesn't have any MQ server installation, so it is using MQ client and it will connect the queue manager. So my application, database application and my MQ server both are in same mission. So how this DB application will connect into this queue manager? Okay, so if application and queue manager both are in same mission, so we can go for client, okay, as well as binding mode. Okay, binding mode. Okay, so when we will go for the client mode, application and the queue manager, WebSphere MQ server. Okay, application and the WebSphere MQ server both are into the different missions. Okay, then we will go for the client mode. Okay, but in my scenario here, okay, application and queue manager both are in same mission. So I have an option. I can go for the client. I can go for the binding. In client mode, okay, in client mode, okay, so we require network. In client mode, we require network. Binding mode, okay, doesn't require network. Client mode doesn't require network. Okay, in a binding mode, we doesn't require any network. So when it will go for the binding mode, application and the queue manager both are in the same mission, then it will go for the binding mode. So basically binding mode means if I am copying some folder in the C drive, I am paste it into the D drive or E drive. That is into the binding mode. So because I doesn't require any network, right? So compared to client mode, binding mode is very fast. For example, if I want to send some data to some files to you, okay, I want the network, right? Compared to client mode, binding mode is very fast, but binding mode is connecting into the one single destination. Okay, so here in the client server scenario, if these queue managers are not available, or maybe this database system subsystem is not available, applications are unable to communicate with the queue managers that is resided on the database end. Okay, so here if you don't have if you are using MQ client, that's middleware system administration also will be reduced. Why? Because you don't have any queue manager on these objects. So simply application will use a interface, message queuing interface to write messages and it read messages from the queue. Okay, that is the reason. So it has been system administration has been reduced. But if the queue managers are not available, unable to communicate with the destination application. Okay, so then that is the disadvantage. So then MQ server to server architecture. So here what will happen, MQ server to server architecture, what will happen is, okay, number of installations will be increase. Okay, so in the server to server what will happen is, I have an application, so here I have a queue manager. So I have a queue manager here. Okay, so queue manager for application. Okay, means if we are able to create a queue manager means, so we have a MQ server installation. So from this queue manager, okay, I have another QMGR for DB. Means here between two queue managers the communication is happening between two queue managers. So this is my DB app. Okay, so here the communication is happening in the between the two queue managers. Okay, so means application is writing messages. Application is writing messages on a queue. Okay, so then the messages will be delivered to the queue. Okay, of the this is my source queue manager. Okay, this is my source queue manager. Okay, this is my source queue manager. Okay, so this is my target. Okay, means source
So
and
in
target
the
application. Here, for
first,
example, if we
in the
have
first scenario, I have a question here. So in the
Hmm.
first scenario, we are all the queue managers will be in the same MQ server, and here it will be in the different MQ server. Is that what you're saying?
Yeah, here in the application and you have a one queue manager. In the target application also you have one queue manager. Okay.
Okay.
So for example, if there is no communication, okay, if there is no communication between two queue managers, or maybe this target application is not available. This target is not available. Okay. This target subsystem is not available. Okay. So your application keep on writing messages in the queue. Whenever this communication is available, so whenever this queue manager is available or whenever this target application is available, that time the messages will be delivered to the destination. If the destination is not available also, source application keep on writing messages in a queue. Whenever the destination is available, that time the messages will be delivered to the destination. That time the message will be delivered to the destination. Okay, so but here, so if we are installing for maybe all our applications are resided on few machines, that is okay. But if we have some 500 applications that are into the, for example, it is into the around 300 machines, so you have to install a number of installations will be increased, that leads into the cost. Okay, so in an organization, okay, for few applications we are using client server architecture. For few applications, okay, so we are using server to server architecture. In the server to server architecture, what is happening, source and application we have a one queue manager, on the target end we have a one queue manager. Between the two queue managers the communication is happening. Okay, so this is the client server architecture. Okay, so another one we have okay, queue, sorry, hub and spoke. Okay, so we can reduce the number of installations here. Okay, so here I have an application. This is my source application, right? This is my source application. Okay, I have another application which is called it as a, okay, DB application. This is my target application. Okay, so in order to, so here I have a one centralized server called it a centralized machine called it as a hub. So here I am installing the MQ server. Here I am installing the MQ server. So for application it use MQ client. So it will connect the queue manager for application. So I created a two queue managers here. Here we have a two ways. Okay, for queue manager for DB. Here also between two queue managers communication is happening in the queue manager to queue manager communication. But application will use MQ client. MQ client it will connect into the queue manager because we don't have any installation on application end. So here also DB application will use MQ client and it will connect into the queue manager. Okay, so MQ client. So here what will happen is the number of installation will be reduced, or you can use MQ client here, or you can use MQ client here. Okay, if you want only one queue manager, for example QMGR. So again this application will use client.
Okay, that acts similar to the first one, right?
Yeah, first one. Either in the hub and spoke, you can follow first one and second one also. Okay, so here what is happening is here. Okay, so if you want segregation, all are the local queues. Your application is for queue.request. Okay, so your application is writing messages on queue.request. Okay, so from here this DB application will read. So again DB want to respond back, right? So again DB application want to respond back. So again you can write the response message in the same queue, but in an organization we require the segregation, right? That is the reason we are using different queues. Okay, if the two applications are using same queue manager, that is comes under the local queuing. Okay, so you can use one queue for request message and response message. Request message will send from the source application, response message will receive from the target application. So here source of target is reading the request message and again it responds back to the source, right? So for request and response messages you can use single local queue. Okay, but we require the segregation. That is the reason. Okay, we are using for incoming request we are using one queue, for response messages we are using another queue. So the source application will use MQ client. It will connect the queue manager. Okay, and it write messages on a queue.request queue REQ. So then DB application will read, again it will respond back to the source application. While responding back it will write message in the queue.response queue. Okay, so then from here source application will read. So this is, we are calling it as a local queuing. In local queuing, so both applications are using single queue manager. Okay, in distributed queuing, so each application will have one queue manager. So between the two queue managers the communication is happening. Okay, that is the difference. Okay, distributed queuing, or we are calling it as intercommunication also. Okay, so in an organization, okay, according to our business scenario we are following these architectures. Okay, so after that, okay, when it comes into the installation, okay, we have to follow few prerequisites. Okay, what are those prerequisites is MQM mount point creation. So what is MQM mount point creation is, okay, so in my system I have a C drive and a D drive, E drive and G drive. So all these are the mount points only. Okay, why mount point is required? So in my D drive I have a 280 GB free space. Okay, and E drive also I have some okay, 32 GB, okay, 32 GB free space. Okay, so in C drive I have only 8 GB free space. For example, I am putting some 20 GB file in the C drive. Okay, it won't take, right? But in D drive I have a space. Can C drive use D drive space? No, right? Hello.
Okay, yeah.
Okay, so if it is not, so that is the reason. For example, without mount point, if you are installing the WebSphere MQ, what will happen? Any other applications are use entire space for WebSphere MQ. If the space is not available, unable to provide messaging and queuing functionality. Okay, so that is the reason.
Okay.
Whenever we are perform using MQ installation, so that time, so we are going to create a one MQM on point. Okay, so for installation around,
So that will have a specific size. We will be determining some specific size
yeah,
and
specific
allocating
size,
the.
yeah, they are allocating. For example, according to your scenario, you can allocate a 10 GB or 20 GB space. Don't think 10 GB required for the only installation. Around 5 to 600 MB is enough. Okay. For example, if the file system, and for example, if the target application is not available, the messages are lying in the queue, right? So for that, okay, according to your business scenario, for this particular mount point, we are allocating the space. Basically, in organization, okay, creation mount points, creating groups and users, all these comes under sys operations. In your organization, your role is a system administrator as well as middleware administrator. You have to perform the mount point creation. Okay. In your organization, only you are into the middleware administrator. So you have to request the system operation team. So on so mission I am going to install WebSphere MQ. These are the prerequisites. Kindly create a mount point for that. Okay, system. So he will provide them create a mount point. Okay. After that, MQM group creation. MQM group creation. Okay. Why MQM group creation? Why MQM group creation is required is, okay. MQM group creation is required is, okay. Only MQM group users. Only MQM group users. Okay. Can create or alter. Can create or alter. Okay. WebSphere MQ objects. WebSphere MQ objects. Okay, so means normally in admin user, in Windows admin user, okay, in Linux we are calling it as a root user. Normally admin user or root user having, okay, all privileges. Okay, so but in if we install WebSphere MQ server on any machine, only MQM group user can create or alter the WebSphere MQ objects. Even root user also not able to create or alter the WebSphere MQ objects. If root user want to create or alter the WebSphere MQ objects, okay, again root user we have to add the root user into the MQM group. Then only he is able to do. Okay. Then
Okay.
okay, MQM user creation. Then MQM user creation. Okay. Then fourth is the once MQM user has been created, then add MQM user to the MQM group. Add MQM user to the MQM group. Then only the user can able to perform either creation or alter of the WebSphere MQ object. Then installation. So installation can be done by root user. In root user means in Linux we are calling it as a root user. In Windows we are calling it as a admin user. Okay. So after installation, then it comes into the configuration. Okay. Configuration of WebSphere MQ objects using MQM user only. MQM user only. Okay, MQM user only. Okay, so after configuration, so using
So it
configuration,
was the MQM
so
user or MQM group?
user group, the users we are adding into the group, right? So using that user, we are configuring the WebSphere MQ objects.
So
Okay?
basically MQM users are the people who belongs to MQM group.
Yeah. The users are belongs to the MQM group can perform the either creation or alteration of the WebSphere MQ objects. Okay. So configuration of WebSphere MQ objects. Configuration of WebSphere MQ objects. Okay. So when it comes into the configuration, so basically we are using commands. Okay. So what are those commands? Okay. Control commands. Okay. Control commands and MQSC. Basically we are calling that is a run MQSC. Scripting commands. Run MQSC. Scripting commands. The third one is the PCF commands. The third one is the PCF commands. Okay. When it comes into the configuration, so as an administrator, mostly we are working with the control commands as well as MKC, run MKC scripting commands. Okay. This PCF command means programmable command formats, means you can use any programming language. Basically, WebSphere MQ is a soft platform independent, right? So we can use any programming language. Okay. So we can execute this. So we can execute. So this we can execute control commands as well as the MKC scripting commands. Means through program we can execute, or we can build the utility using PCF commands. Okay. Okay. So we will discuss in tomorrow session about these commands. Okay.
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 Yeah.
Okay. Okay. Okay.
Yeah. Fine.
So you understand, right?
Yeah, I got it.
You have got it, right?
Yes. Yeah.
Okay. 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 Okay.
Okay. Thanks, Naren. Login.
Okay. Fine. That's okay. Fine. Thanks.
So now there's one question before we close. Do we need what system configuration we need if we need to install something for practice?
No, normal Windows it is enough. If we have a 10 that won't support. Okay. So
I have XP. So and so I have 7.
Yeah. You have 7 that will support. 7 XP all are support.
Yeah. Okay. And it's a 32-bit operating system will support, right? Windows 32.
Yeah, 32, 64 both will support.
Okay. Fine. Okay.
Okay.
Yeah.
Okay. Fine.